Hi there. In this video, I want to go over with you the basic configurations of pumps. And there are a lot of configurations, but there's just four that we're going to talk about. The four being RWB, RWT, RHA, and THC. And this is our official pump diagram. You may have seen this already. If not, you will see this again. We keep it in the pump shop. It's just a good reference for these configurations or styles of pumps and all their parts. But in this video, we're not going to be focusing much on the individual parts that are listed out here. We're going to be focusing on the configurations as a whole. So to start, let's talk about RWB, probably the most common one. So we can talk a little bit about what these letters mean. So any code prefix with R stands for an insert pump. So it's a rod insert pump is what that stands for, meaning that it's not a tubing pump. You can see three of these start with R. One starts with T. So that would be a different style or very different style from these three. But the ones that start with R mean it's an insert pump, which means your pump is totally separate from your tubing. The two aren't connected. You can pull your pump out of the hole without having to pull any of your tubing. Um, the W has to do with the barrel. Right here, this next letter is the barrel. So a W would be a thin wall barrel, as opposed you see an H here and an H here. H would be a heavy wall barrel. So this would be a thin wall barrel. The B stands for where the hold down is. This the B in this one means that it's a bottom hold down, um, as opposed to, we'll look at this one, like RHA means it's a top hold down. So, and we'll go over each one of these as we get through them. But so for RWB, it's an insert pump, thin wall barrel, bottom hold down is what that's talking about. So, and here's a basic schematic of that pump. So here is the barrel and seating assembly, and here's the plunger. This plunger would fit into the top of this barrel, and the rods would use the valve rod to stroke the plunger up and down within the barrel. And I will actually draw that out for you real quick so you can kind of get a better idea. So I'm going to make a real crude drawing here. Do the best I can to keep it clean and simple. Okay. So let's say this is our tubing right here. So again, this being an insert pump, it fits down inside the tubing. The two aren't connected. And I'm going to come down here and draw a seating nipple. Okay, so right now we've got our tubing is this out here, and then our seating nipple is this out here. I won't draw anything below that, but you might have, you'd probably have a mud anchor below that, but we won't go over that in this video. So for an RWB type pump, it is an insert pump, the bottom hold down. And so I'm going to draw the hold down that first. Let's say this is the hold down. I'm going to draw a little bit smaller. Obviously, I'm not drawing to scale. These margins would be really tight. Obviously, the hold down would fit very tight in here. I'm just trying to draw you a crude example of what this pump would look like. And I'll draw a little. That would be like our strainer nipple right there on the very bottom. And then let's draw the pump itself. Oops, dadgummit. Hold on. Let's see if I can fix this. Ah, there we go. That was easy. I think I clicked the back arrow on accident. Copy this. Oops. Okay. That's That's pretty good. So far we have our tubing on the outside, seating nipple, got the seating assembly and a strainer nipple, and then this would be the barrel of the pump. And so the plunger then, let's draw that next. Actually, I'm going to move this down just a hair, right about there. Plunger, and then I'll draw valve rod. And then, not sure how good I can draw it, but I'll make a little bit of an attempt. On top would be like the valve rod guide. Just kind of draw it like that. Okay, so here is a basic schematic. I'm going to make this plunger shorter so it looks like it could actually move in here. Yeah, we'll go like that. Um, so this would be like the basic outline of an RWB. So it's a rod pump, or an insert pump, meaning the whole pump, barrel, plunger, seating assembly, everything fits down inside the tubing so that when they pull the rods up out of the hole, they get everything. They get the pump. They get the complete pump. You don't have to pull tubing to get the pump out. That's kind of the advantage of this of an insert pump. And the thin wall, so R, that explains the R. The W is the thin wall, just meaning that it's a thin wall barrel. We'll go over heavy wall barrels next. There's a little bit of a difference there, but just know that this is a thin wall barrel. And then the most or the another important part is the B, meaning it's a bottom hold down. So you can see because the hold down is on the bottom of this pump, the whole pump is up inside the tubing. Um, One nice thing about that is it equalizes pressure on the inside and outside. So, I mentioned this being a thin wall pump, so it can't hold as much pressure as a heavy wall pump, right? But since you've got it as a bottom hold down, pressure on the outside of the pump, hydrostatic, is going to counter the pressure on the inside of the pump. So you don't need a real thick barrel, because the pressure differential between here and here is never going to be that much. The downside is if you have a lot of solids in your oil, if you're pumping solids through here, um, they will fall down as they come out here, fluids moving up this way into the tubing. As those solids come out here, they will fall down the sides of this pump and build up down at the hold down and build up along the sides of the pump. And that can make it very difficult to get out, sometimes impossible. If that's a big enough problem, you actually won't be able to get this pump out. And then you'd have to actually pull tubing to get it. So this is I hope that at least explains this pretty good. This is the most common one, um, but I guess I don't have anything more to say on that. So let's move on then to the next one. Which is RWT. So actually, I'm going to save this. We'll do this one third. Let's talk about RHA next, because it's actually very similar to an RWB, with some key differences. But as far as how it functions, it's different. The main key difference is that the hold down is on the top. So if you look, your mandrel, your cup and spacers, your lock nuts, they are all up here on this one versus on on RWB, you see your mandrel, your cup and spacer, your lock nut, your seating assembly, it's all at the bottom. So let's just draw the difference there. So I'll go ahead and erase some of this. Okay, so we're back to just our tubing and our seating nipple. So that's what I want. Like I said, on the RHA, let's go ahead and draw. I'll draw a little bigger this time. Actually, no. Keep it small. Okay, so there's our seating assembly. But this time, this is going to be at the top of the pump. Um, and so, let's talk about that H. Let's talk about the difference between the thin wall and the heavy wall. So, if you do look at these parts, I said we wouldn't talk about parts much, but we are going to have to talk about them a little bit. If you look at the parts on here versus the parts on here, you're going to see a few parts, additional parts on this that make this work. Two of the main ones being the extensions. Yes, you've shown an extension here and an extension here. Um, those go on it's pretty common. You don't have to do it this way, but it's very common on heavy wall barrels to have an extension on either end, and I'll talk about why here before too long. So when I draw this, I'm actually going to draw those extensions first. So let's do that now. So okay, and then next I'm going to draw the barrel. Okay, and then I'm going to draw another extension down here. Won't go too long with it. Okay, so again, we have the seating assembly, which is on the top of the pump. You can see the whole pump is below. I'm drawing it below the tubing, and then we have an extension, the barrel, and then another extension. And I'm going to go ahead and draw. So just draw that. This kind of like, this is the base of the pump. And then we'll just draw a little strainer nipple down here as well. Okay, so there we have our completed barrel assembly for an RHA. So again, back to the H, you can see the difference, and that the barrel is kind of three parts here. You have the barrel itself and the barrel extensions, one on top and one on bottom. And this being a heavy wall barrel has male threads on either end versus a thin wall barrel has female threads. So you can't fit extensions directly onto a thin wall barrel. They're meant to go on heavy wall barrels. And again, I am getting to the reason why this is. Um, but just know that for now. So let's go ahead then and draw the plunger. And let's see, how do I want to do this? Start with the plunger right here. Okay. And then draw the valve rod. I'll do this two pieces. So here's the valve rod, and then I'm not going to draw it through this. I'll draw it coming out above it. Actually, I think I can just oops, copy this one. Yeah. Okay. So we're going to say this is a continuous rod. I'm just drawing it through here so that the picture looks a little bit better. Then we can draw our, this would be like our valve rod guide right here. All right, I'll draw this one to stretch up a little higher. Okay, so once again, we have our seating assembly. We have our top extension. We have our barrel. We have our bottom extension. Inside that, we have the plunger and the pull rod. And The main difference, the main reason you have these um, extensions is to allow the plunger to move out of the barrel on both ends. So you can see because there's space above and below the barrel, the plunger can actually clear. The way drawn it here, the plunger can come up above the barrel and clear it completely on both the top and the bottom on each stroke. And the reason for that is scale and just junk in general can build up on the parts of a barrel that the plunger does not stroke through. So like I showed you before on that thin wall barrel, the plunger isn't going to hit every part of the barrel. The parts that it does wipe through, it will keep clean and it will stop things from building up. But the parts that it doesn't hit, junk is going to build up there. And when you go to pull the pump, you'll end up pulling your plunger up into that junk. And it makes it very hard to separate the plunger from the barrel. And so that is the main thing that the extensions overcome is that the junk, instead of building up real tight in the barrel, will build up in these extensions where it's got a little bit more space to do so. And so when you go and pull the pump, you're at least not pulling it into a very tight space. You've got some room to work with there. Um, and so that's the main outline of an RHA pump. Just the main thing to remember is that it's another type of insert pump. It's still inserts separate from the tubing. You run tubing first, then you can run your pump. If you need to pull your pump, you can pull it without touching the tubing. Um, but the main thing to remember is that the A, RHA, that A means that the hold down, I'll show it over here on this diagram once again, just to really drill it in. The hold down is on the top. I kind of think of it, it's easy to think of this as bottom over here. If you think of that B, it could stand for bottom since the hold down's on the bottom. It really doesn't though, because A, it's like, well, that would need to be a T, and there is a T, but we'll talk about that in a minute. But that does not stand for top. Um, A So I like to think of it as the top is the A position and the bottom is the B position. So you have position A and B for the hold down. A is what's on top, B is what's on bottom. That's kind of how I remember those. So those are your key differences between the RWB and the RHA. Another thing I think that is worth mentioning before, when I talked about the RWB pump, the bottom hold down, where so the whole pump was up inside the tubing. Well, on a top hold down pump, an RHA, the whole pump is below the tubing. And so you don't have that problem where if you're moving solids and junk through, they don't come and accumulate right here. There's nowhere for them to accumulate because fluid is moving. This fluid or this pump is forcing fluid upwards through here. And um, any solids that try to build up on here are just going to continually get swept upward with the current of the fluid being moved. There's no nice still place for them to settle with this pump. Another thing I talked about on the last one was the relatively low difference in pressure inside the pump versus outside. Well, if you think about it, inside your tubing, you've got this column of fluid, right? But below it right here, the seating nipple seals it off. So this is very high pressure. This is an area of very high pressure right here because it's got the hydrostatic weight of the entire column of fluid right here. But right down here, it doesn't. Presumably, if your well is pumped off, you don't have much of a pressure right here at all. And so since if that hydrostatic is in here, it's also in this pump as well. So you have a big difference here is that you have a very big difference. There's very high pressure inside the pump versus very low pressure on the outside of the pump. And so that obviously being a big pressure differential, you need a stronger barrel for the most part. It can depend on the depth. You can run a thin wall barrel as a top hold down. That's not at all a problem if it's a shallower depth well. But for the most part, your top hold downs, you're going to see a heavy wall barrel, and it's because of that pressure differential inside the pump versus outside. So, anyways, I hope that all makes sense. Let's go back to our diagram. And we will move on to RWT. So what does this pump mean right here? So we can tell it's an insert pump. We know that it has a thin wall, but what does this T mean? And that stands for it's a traveling tube type pump. And on this one, so on these first two, the barrel seats into the seating nipple and the barrel stays still. The barrel is stationary. The plunger moves up and down. On a RWT type pump, that is exactly the opposite. The plunger is the thing that gets seated into the seating nipple, and the barrel is the thing that moves up and down. So let's go and just draw this real quick. Got everything. Yep. Okay, so we're back to we just have our tubing and our seating nipple. I'm going to start again with the seating assembly. So let's pretend that's our seating assembly. Again, we'll draw a little strainer nipple down here. Okay. Now on this one we talked about the plunger is what is held to the seating assembly. And it's held by, instead of this type of pump does not have a valve rod or a pull rod. It has a what they call a pull tube. I'm going to draw that. Oops. Just like this right here. I'm going to make it a little shorter. Okay. So you've got your seating assembly, and then on top of that you'll have a pull tube, and on top of that you will have your plunger. Okay. And on top of that, I'll go ahead and draw the barrel. So let's use this tool. Those are a little slanted. I'll try to straighten them up some. Make it look a little better. I'm going to widen up that plunger too. Just a little. Okay. And, whoops, that's not what I wanted. Okay. So, like I mentioned on an RWT, that T is for traveling tube. So you can see on this one that I've drawn, the plunger is the thing that is fixed. It is held stationary by the seating assembly. And the barrel actually moves up and down. So this would be your rod string right here. And obviously fluid could move through this part. I didn't draw it that way with holes in it, but there would be gaps in here where fluid can move through and continue up the tubing, right? Um, it all works on the same principles, but the only difference is this barrel is actually what's moving up and down, not the plunger. Plunger sits still. Um, that is its difference between the RWB and the RHA. The RWT, the barrel moves, and it's This pump takes several different components to make this work. Obviously, I talked about like this pull tube. It doesn't have a pull rod, it has a pull tube instead, because fluid needs to be able to move through this. Um, but that is the big difference, is that the barrel is the thing that moves. This could be a thick wall barrel as well, in which case that would be an RHT. Switch that W to an H, would be a heavy wall barrel. But again, because let's look at the diagram that I drew. It's a bottom hold down type pump. Obviously, you cannot have you cannot have a top hold down traveling tube style pump. It just, if you think about it, it just wouldn't work. Like that just can't happen. So you can know any traveling tube style pump, it's going to be a bottom hold down. And so you don't have a big pressure differential between the outside of your pump and the inside of your pump. So typically you see these with a thin wall barrel, though it is possible you could easily make this with a heavy wall barrel if you needed to for some reason. But we don't see a lot of these. 98% of our pumps are RWB or RHA. We've got a handful of, oh dang, I'm terrible at this. We've got a handful of the top hold down, or sorry, the traveling tube style pumps, but you don't see a lot of them. Another, I've mentioned with the other pumps, one nice thing about this is nice in cases where, let's say for some reason you cannot run a top hold down pump. Maybe you don't have the space below it. For a top hold down pump, the whole thing's got to fit below the tubing, so you need space all down here to do that. Well, let's say you don't have that space, but you also have the problem of solids accumulating on the outside of your pump. Well, this pump overcomes that, um, because the barrel is constantly moving. It is wiping this space on the outside of the pump. So this space where junk would normally pile up, the barrel is wiping that clean, on every stroke, and so you don't have a big problem with the barrel getting stuck because, well, the barrel's moving the whole time. Um, and so I I hope pretty much explains this style of pump. So let's go ahead and talk about the last one. So all these others have started with an R. This one starts with a T. So that is telling us it is a tubing pump, meaning that it's not an insert pump and that the tubing and the pump work together. So that means that if you want to completely pull the pump out of the hole, you're going to also have to pull tubing. This is a big downside to this pump. Um, the upside to this pump is it gives you a lot more capacity for the size of pump that it is. So if you think about these pumps, well, the whole pump has to fit inside the tubing. That downsizes everything. Everything has to get smaller for this to fit inside the tubing. Well, this one, it's built into the tubing. You get the full capacity of the tubing to make your pump work, and so you can move a lot more volume for the size of pump with a tubing pump. And so let's go ahead and draw that out. Just gonna erase a lot of this stuff. Um, that included. Okay, so with a tubing pump, usually the first thing, you don't have to have extensions on them, but usually they have extensions. So I'm going to draw that, and that's similar to an extension on like an RHA type pump, a heavy wall pump, because as far as I know, all tubing pumps are heavy wall. Um, so let's draw it that way. Yeah, and this diagram does show an extension on the top and bottom, so I'm going to draw it that way as well. Oops. So here we have our tubing, and you notice I removed the seating nipple on this one. We don't have a seating nipple just yet. And let's draw, this will be our top extension. Draw it like that. I think those are just a little slanted. Okay, so there's our top extension, and you can see now it is connected to the tubing right here. It's not seated into a seating nipple. These extensions, this pump is screwed straight onto the tubing itself, meaning if I want to get this stuff out of the hole, I got to pull the tubing. So the next thing, let's draw the barrel. Looking pretty good, and down just a hair. Yeah. Let's draw the bottom extension now. Okay, good enough. All right, so there is our barrel with a top extension and a bottom extension. And if you notice with this one, it is not inserted into the tubing. It's attached to the tubing. So when you go to run this pump, the first thing you do is you run your barrel and then you run the tubing all with that. And so tubing and barrel are attached. Um, and so on this one, let's draw like this. Oops, actually not like this. We have a seating shoe. So we don't call this the seating nipple. It is actually called the seating shoe. I'm going to draw it pretty short. Tubing pumps, for the record, do not have a seating nipple. They have a seating shoe, which is very similar in concept, but is just a little bit different, enough that they give it a separate name. So we have our tubing up here. We have our top extension. We have our barrel. We have our bottom extension, and we have our seating shoe. So what about the plunger and all that, and the seating assembly and everything? So the way this pump works, when you run it, like I mentioned earlier, you run the barrel with its extensions on the bottom of your tubing string. So you put it in the hole first, you run all the tubing behind it, barrel ends up all the way down here at the bottom of the hole, or wherever you want to set it. Um, and then when you go to run your rods, that's when you run your seating assembly and your plunger. And the way it's run, I'm going to actually go back to the diagram for this. Okay, so here's our barrel and extensions with the seating shoe on the bottom right here. And then over here is drawn our seating assembly. So it's going to have your standing valves and your plunger with your traveling valves. So how then, if you don't run the seating assembly when you run your barrel and extensions, how do you get it down there and separate from the plunger? So I mentioned before you run your plunger with your rods. Well, actually, you run this at the same time as well, but they're connected together. So you see this part called a standing valve puller is on the bottom of this. You actually can screw your seating assembly onto your standing valve puller. So you can connect these two parts and run them together. Now then, when you get your plunger all the way down into your barrel, you can seat this. You can seat your seating assembly into your seating shoe, turn the rod string counterclockwise or to the left, and it will disconnect your plunger from your seating assembly. So then you run them together, but then you separate them, and now your plunger can stroke free of your seating assembly, and you have your standing valves and your traveling valves. So let's go and draw that just the best that I can. Oops. I'm gonna draw them together first. I'm gonna draw them as if they were still connected. So when you run the pump, let's go ahead. This will be our seating assembly. Put a strainer nipple on the bottom of it. That will do. Okay. And then I'm going to draw, say this is our standing valve puller and our plunger. Okay. And then attached to the top of that, you actually have your rod string. Oops. So when you run this in the hole, you're running it with your rods. Make this pretty long. So this goes all the way to surface. Oops, I just moved it. My bad. Okay. So you run your on the very bottom of your rods. The first thing you run is your plunger, your standing valve puller, and your seating assembly with the standing valve and all that on it. So these are all connected. Now then, when I get it down here, I've run this all down. I felt that it's hit the seating shoe and that it's seated. Now then, I will rotate this whole thing, will rotate the rods counterclockwise, and it will unscrew this part from this part, and they'll separate. So let's see if I can select all this stuff and move it up together. It's not going to let me, is it? I'll have to move them one at a time. So let's just do that. Move this up just a little bit more. Okay. So then after you've got your seating assembly seated, you unscrew from it and you move up off of it, and now your plunger is free from your seating assembly and your standing valves and can stroke up and down inside the barrel. So again, um, one of the main benefits of this style of pump is you get a much, you saw I drew all this stuff much bigger because it's all the size of the tubing. You get the full size of your tubing to build your pump. That gives you way more volume. You can move much more fluid per stroke. And so this would be for like a high volume well where you need to move a lot of fluid. Downside is it's not all connected. If I want to pull the entire pump, I have to pull the tubing too. A lot of times the problem will just be with either this or this. And if I want to pull the plunger and the seating assembly, I can. I don't have to pull tubing. I can come down here, lower this on, screw it back on, and pull all that up out of the hole. But if I get a hole in my barrel or in one of my extensions, well, out of luck. You're just gonna have to pull tubing. There's no other way around it. Um, Heavy wall barrel, because again you've got the full hydrostatic pressure on it. I don't think there's such thing as a thin wall barrel with a tubing pump. I think they're all heavy wall. You don't have to have extensions. You can build these without extensions on them. But again, it does give you that benefit of where the plunger, you can see the plunger can clear the barrel on both the top and bottom of the barrel. And again, with just crud building up, it's not as tight when you go to pull it. Um, let's see here. I guess as far as sediment, you don't have a space for sediment to build up on this. Fluid is moving all up above this plunger. There's not really anywhere for sediment to build up. Um, let's see. I think that's all I want to cover with this one. I hope that makes sense to you now of what each one of these RWB, RWT, RHA, and THC means. I hope I've explained it good enough and that the diagrams I drew make sense. Look at this, study this, understand it. If you have any questions, ask your supervisor. Figure it out. Um, because we want you to know this stuff backwards and forwards. So thank you so much for watching, and I hope you learned something from this video.